Hello and welcome class. So in last class we have completed equation of motion topic where we learned about three equation of motion and how to apply it. And with that topic we have finished the part motion along a straight line. In today's class we will start a new topic which is uniform circular motion, the second part of the motion, and with this topic, this chapter will be finished. So let's start the topic uniform circular motion and try to wrap up this chapter. Uniform circular motion. In the beginning of class, I have explained you that motion are very complex. They are of many type, but in class 9th, we will study about two type of motion. First was motion along a straight line and second was uniform circular motion. And we are going to start this topic uniform circular motion. And what does it say? When the velocity of an object changes, we said that object is accelerating. When you continuously change the velocity of the object, it means you are providing that object acceleration or retardation. So we say that object is accelerating in positive or negative, both way. The change in the velocity could be due to change in its magnitude or direction of the motion both. As velocity depends on magnitude as well as direction, then the change of velocity could be due to change in magnitude or in the change in the direction. Clear class? So that's how we can change the velocity of an object by giving it acceleration. Okay, with when you will provide it acceleration or retardation, its magnitude will get changed, but when you will change the direction, velocity also can get changed. Can you think of an example where an object does not change its magnitude of velocity but only its direction of motion? Can you think? So, can you think of such an example where you change the direction of the object but did not change its magnitude and the velocity gets changed? And the example of such case is uniform circular motion. Let's assume we are on a rectangular track. Till here, let's suppose the velocity in all the direction is same, 10 meter per second, 10 meter per second. The speed is same. Speed is same, but the direction is getting changed. And because direction is getting changed, so velocity will change. Clear class? So this is an example where object speed does not change, but velocity change because direction is changing. First, the direction was west, then south, then east, then north. So, direction is continuously changing, but the speed remains constant. Speed remains constant means magnitude remains constant. Okay, magnitude remains constant, but velocity will get changed because direction is changing. So this is one of the example where an object velocity may get changed without acceleration because the direction is getting changed. This is also an example where speed remain constant but velocity change because direction is getting changed. So any object which change its direction, okay, this is also another example, hexagon track. Okay, direction is continuously getting changing, so velocity gets changed. And a circular track, here at every point direction will get changed, every point, but the magnitude remains same. Magnitude remains constant, but direction is changing continuously so velocity is changing continuously. Clear class? So any person or any bike moving in a circular track is an example where the magnitude or speed will not get changed, but because direction is continuously changing in every single point, so its velocity is changing. Clear class? So we have studied about the example of a rectangular track. Okay, the athlete may be moving with a uniform speed. It means magnitude is constant, speed is same. It means the velocity's magnitude, which is speed, is constant. Speed magnitude is constant, but direction is continuously getting changed. Okay, at every corner, okay, direction is getting changed. And how many times the direction gets changed in a rectangular track? 4 times. So its velocity is getting changed. When an athlete runs along the hexagonal shape, hexagonal means 6 sides, so 6 times its direction will get changed. Okay, octagon, at octagon shape, 8 times the direction will get changed. So it is observed that as the number of slides of the track increases, the athlete has to take turn more and more often. How many times? Okay, if the number of sides are changing continuously, the athlete has to take more turns and more turns. What happened if the person has to take infinite number of uh, uh, sides? It means that the person is moving in a circular track. In circular track, you have to change your direction every single point. In circular track, you have to change direction in every single point, and there are infinite many points in a circle, so you are changing direction infinitely. It is observed that as the number of side of the track increases, the athlete has to take turn more and more often. Okay, often. What will happen to the shape of the track as we go on increasing the number of sides infinitely? Yeah, indefinitely. If you want to increase the side of the shape indefinitely, what is going to happen? That shape will approach to circle. If you do this, you will notice that the shape of the track approaches to the shape of a circle, and the length of each of the side will decrease to a point. So a point will become a side and shape will become circle. Is it okay, class? If you increase the number of rectangle has 4 side, hexagon has pentagon has 5 side, hexagon has 6 side. Okay, octagon will have 8 sides. So how number of sides you increases, the shape will become more closer to the circle. And if you increase the number of sides continuously, the shape will become close to circle and each side will become a point. Clear? if the athlete move with a velocity of constant magnitude along the circular path, okay, if the athlete moves with a constant speed or the magnitude of velocity is constant, then the only thing changing in the circular track is the change in the direction of motion. Okay. If the athlete moves with a velocity of constant magnitude along the circular path, the only change in his velocity is due to change in the direction of motion. Change in the direction of motion. So in circular track, direction is changing continuously. Direction is changing continuously. The motion of an athlete moving along a circular path is therefore an example of an accelerated motion. Okay, this is an example of a accelerated motion, and if this circle has the radius r, then what will be the length of this track? The length of this track is equals to circumference of a circle. And what is the formula for circumference of a circle? Circumference is 2 pi r, where pi is 22 by 7. This is the formula of the circumference of the circle. And what is circumference? The path length of this circular track. Circumference of a circle. Clear, class? Okay, so it is clear to us. And what will be the speed of that? Let's suppose an athlete begins from here and then covers the whole track and again finally reach at this position in t time. Then what will be the speed? I'm not talking about velocity, because velocity will be 0 because displacement is 0. So what will be the speed? Speed is equal to distance divided by time. And how much distance this object has covered? The distance is the circumference of this track. And what is the circumference of this track? Circumference is 2 pi r. So speed is 2 pi r divided by time t. So when an object moves in a circular path with uniform speed, okay, uniform speed is an important word here. When an object moves in a circular path with uniform speed, speed is uniform, speed is constant, only direction is changing continuously. So this type of motion is known as uniform circular motion. Clear, class? This is the definition for uniform circular motion. Now let's do one activity. Take a piece of thread and tie with a small piece of stone, and at one of the end, move the stone in a described path. It means you have to take a piece of a long thread. You have to tie a stone in the bottom or at the one end of the thread and start moving the thread in a circular shape and try to hold another end of that stone, okay, like this. Okay, this is your long thread, this is the stone, and you are doing this type of motion so that the object is moving in a circular path. Okay, then you will realize that you are giving same velocity, but because of this motion you are changing the direction continuously, and this object is doing a uniform circular motion. Speed is constant. Speed is constant. Direction is changing. So this is one of the example of uniform circular motion. Okay. Let the stone go by releasing the thread. Can you tell the direction in which the stone move after it released? Okay, you can guide the direction according to your convenience. You can move that stone in anti-clockwise or in clockwise direction. By repeating the activity for a few times and realizing the stone at different position of circular path, check where the direction in which stone moves remains same or not. You can check continuously that is the direction of the stone changing at every point or not, and you will get the answer that the direction of the stone is changing continuously. If you carefully note, on being released, the stone move along a straight line tangential to circular path. So at every point, stone is trying to move in this direction, but you are holding the stone in this direction. So stone change its direction in this way. Here, stone wants to move in this direction, which is the tangential direction. Tangential. What is the definition of tangent? When an external line outside from the circle is touching the circle at one point is known as tangent, and you will see that the stone is trying to move in tangential direction and you are holding the string in this direction, so stone is moving in this direction. If the stone moved here, then its direction will be tangential, string is here. If stone moves here, its direction will be tangential, but string is pulling inwards. Okay, and that's how this stone will continue on a circular path. This is because once the stone is released, it will continue to move along the direction it has been moving at that instant. It will continuously moving in the direction where it has been moving at that instant when you release the stone, and this show that the direction of the motion change at every point. At every point, the direction of motion is getting changed. So, in uniform circular motion, the direction changes continuously when the stone is moving along the circular path. Clear, class? When an athlete throw a hammer or a discus in a sports meet, okay, if you ever watched Olympics or any sports activity, you will see that athletes, there is a competition where athletes try to throw a discus. Discus is a circular plate. Okay, when you throw it with a certain angle, okay, it will go to the maximum distance. Similarly, happen with a round hammer. Okay, this is the hammer, and this is the belt. Uh, you grip the hammer by belt and you give it a circular motion and try to release it. When you release it, okay, the circle was moving at its tangent. When you release it, it will move at that direction where it get released. It was released. So when an athlete throw a hammer or discus in a sports meet, she hold the hammer or discus in his hand and give it a circular motion by rotating his hand, uh, her own body. Okay. Once released, when you released this disc or hammer, first what you do? You grab this hammer or this disc in your hand and you try to rotate in a circular motion, and then you release it. And when you release it, it will go in that direction where you have just released at that movement. Once you release in the direction, in the desired direction, the hammer or discus moves in the direction in which it was moving at the time it was released. Okay, it will moves in the direction which was it was moving at the time in which it was released, just like the piece of stone in the activity described. Okay, the stone always want to move on tangential direction, but because of thread, okay, it was changing its direction. If there is no thread, then that object will move in tangential direction, and similar is the case of the disc. When you give rotation, your hand act like a thread. You rotate your whole body, okay, so you are giving it a circular motion, and when you release it, it will move in the tangential direction. Clear, class? There are many more familiar examples of object moving under uniform circular motion, such as the motion of moon and the earth, satellite in the circular orbit around the earth, cyclist on a circular track at constant speed, and so on. There are many more examples of the uniform circular motion, such as earth and moon are attached by an force, and moon is revolving around the earth. So moon is doing a circular motion. Moon always want to follow its tangential path, but because of the force of gravity between earth and moon, the moon is doing circular motion. Okay, and with this topic, this chapter is complete. We have completed chapter number 7, motion. We have first learned what is motion. We have learned motion in a straight line. Then we studied what is distance, displacement, initial point, final point. Okay. Then speed, velocity, acceleration, then their graphical representation, then equation of motion, and finally the uniform circular motion. I hope this whole chapter is clear to you. Thank you so much.